And we are going live. Okay, you are good.
Okay. Hey everyone, welcome to Dome to Home. We're gonna get started in a minute or two here. We just wanna give everyone the chance to get signed on and refresh the stream if they need. So, while we're waiting,
Hi,
hello
Dylan.
everyone.
We see you in the chat. We're hoping you're just as excited to get started as us.
Hope so. We're excited to get going today. So welcome everybody, returning people, new people. Great to see you. Our regular viewer, Denise, over there. So how are we feeling? Should we get going?
I think we're probably good to go with our few minutes of, or our 1 minute of technical difficulty.
All right, let's go ahead and get going then. Hello, everybody. Welcome to Fiske Planetarium's Dome to Home series. Today's video is for middle and high schoolers. So if you are in middle or high school, awesome, this video is for you. If you're younger than that, you can stick around if you want, but you might want to check out our K5 videos. If you're older than that, awesome, welcome. So my name's Rémy. I'm a student at CU Boulder and a presenter at Fiske Planetarium. Below me is...
Hello, my name is Amanda. I'm a navigator at Fiske Planetarium. I'm a senior this year, but I'm really enjoying working from home and helping out with the Dome to Home series. Hopefully you guys are enjoying it just as much as we are.
Awesome. Yeah, so Amanda's going to be taking care of all of the visuals that you see over here on the screen in real time. So every picture that pops up and every movement you see is all thanks to Amanda. Also helping us this week is our question master behind the scenes, Brianna, and our chat moderator for the day, Jeremy. So this week we'll be learning about galaxies and the universe, which is a really big topic.
Yep, and also just so you guys know, we are having a little bit of technical difficulty on my end. I don't have those high quality computers for the great streams. So every once in a while, we might freeze for a second or two, but hopefully it will smooth itself out and we can have a not too crazy distracting stream. So Rémy's arm is frozen right now, but she's just displaying how much she loves the dome. So hopefully it'll fix itself here soon.
We can roll with that. It works. So if we freeze, no worries. We're okay. It's just the screen. So universe, galaxies, it's a really big topic. So for the sake of not keeping you here all day, which I could talk all day, I promise, but I won't, there will be a few things that I won't quite get to. And depending on your questions, tell me what of the things that I don't get to talk about you really want to know at the end so that I make sure that we address everything that we want to learn. So definitely make sure to stay active over there in the chat box, which is either here or there. And let us know what it is you want to hear about. So let's get started. Beside me on the dome, you may recognize our common starting point, the outdoors. So let's lay down and look up because I'm going to take a look at the sky again from Earth before we really get going. There's my arm again.
Such a beautiful day to be laying down in the grass, staring at the bright blue sky, nice bright sun. The weather is warming up. It's a great time to be laying outside.
It's a little warm, but I'll roll with it. So let's get rid of that pesky sun. We love the sun, helps us out a lot. Makes it tough to see other stars though. Way too bright. Get rid of it.
We're gonna kill the sun, get rid of it.
All right. And as the sun goes down, we can see all those nice stars. And we're gonna go to the middle of the night to see what I really want to see. What time are we going to, Amanda?
We are going to stay up early and we are going to go all the way to 3 a.m.
3 a.m. Make sure you're asleep before that.
Got to get your pre-3 a.m. nap in for sure.
All right. So what you can see here, And you'll see a view like this if you can move away from city lights. Is the stars and this huge band here across the sky. It's a huge piece of our night sky, which means that the same way that cultures around the world make different patterns with the stars, constellations, they also came up with stories about this huge path. You know, some saw a river, some saw a path for birds, and some thought, hey, that looks a little bit milky, doesn't it? And that is where the word galaxy actually comes from. It's the Greek word for milk. And you can probably guess by now, this band is the plane of our galaxy, the Milky Way. So it's not just stars. As we saw last week, we also have huge clouds of gas and dust. So what we're seeing here are stars, gas, dust, and those dark bands there. Those aren't where things aren't. That's just where some of the dust is blocking us from seeing past there. Beautiful. So galaxies are just these huge clumps of matter in the universe found in galaxy. It's all held together with gravity. So the same way that gravity is holding things together like planets and keeping planets around their stars, it's also keeping galaxies together. So let's go see what exactly that looks like.
Make sure everybody's got their seatbelts on. We're about to take a wild ride out into space, and we are going to go far. So hopefully you guys don't get too homesick. We're going to see a lot of cool stuff. But yeah, make sure to take one last good look at Earth before we head out.
Bye, Earth. So let's get going. So we're going to go really far and we're going to go really fast. There is no way that we could possibly go this fast. We will be going much faster than the speed of light. As we're leaving, you can see the orbit of the moon. Here are the orbits of the planets around the sun. We don't care about planets today. If you want to learn about planets, we've got a tour of the solar system. And down here, Amanda has put a counter on how far away we are. So when you see AU as the unit, that's how many times the distance from the sun. So we're one astronomical unit, one AU from the sun. As we get further and further, we'll change it to light years so you can get an idea of how far. And notice we have to go really, really far to get to another star. And we have to go even further to get outside of our galaxy.
Absolutely. A lot of these stars in the sky are the stars that make up constellations, and the constellations get super warped because stars that look like they're close together in the night sky are not close together in the night sky or in the galaxy.
Yeah, can we put up the lines actually so you can see just how far apart some of those stars are?
Absolutely. Let's look at the zodiac constellations.
Yeah, so usually when you think of constellations, they're pictures, they're patterns in the sky, but that's all just based on our angle. So you see these stars are actually really far apart, behind or in front of each other, but as far as where they are in our sky, it kind of looks like they're near each other. Another thing you'll notice is that they're actually really, really close to us, these stars. So the stars that we can see individually are really, really close to us compared to the rest of the galaxy.
You can kind of see that little bubble pop up. I know it was a little bit late, but those are all of the stars that we can see in our night sky. Just like Rémy said, they're super close to where we came from.
Now we can see our whole galaxy, and I want to mention that this isn't a photograph of our galaxy. This is computer generated, and any image that you see of the Milky Way from outside the Milky Way is either going to be a drawing or a computer image. So sending a camera all the way out here would take far too long. Even at light speed, it would take tens of thousands of light years to get all the way out here, possibly over 100,000 light years. We're 70 away from home. No, we are extremely far away so that we can see the whole thing, but we can't send anything out that far. So how do we decide what it looks like? It's kind of like trying to draw your house, but you can't leave your house. So you're stuck inside your house, you can't leave. There are a lot of methods you could use if someone says to draw your house. You can go around and you can count how many rooms there are. You can see where the stairs are, you can see where the windows are, and you can look out the window at the rest of your neighborhood and see what the other houses look like. And you can start getting a good idea of what your house might look like. So what we do is we see how stars move around us, and we also look at other galaxies like these to get an idea of what our Milky Way looks like. We're pretty confident on this. So the Milky Way is what's called a spiral galaxy, and it has a very specific structure with three main parts. We got the disk, the bulge, and the halo. So if we take a look from the side, we can see them really well. Thank you, Amanda.
Absolutely. I love looking at the plane of our Milky Way.
Here we go. So you can see as we're coming up edge on, you've got it really flat, and that's going to be the disk. So that's all those spiral arms are in this disk. And you see in the center there, you've got kind of a brighter area right there, and that's going to be the bulge. And the halo is all the stuff that's around it. So if we go back to looking top down, we can see what's happening in each of these sections. So if you look at the disk and those spiral arms there, you'll notice that they're different colors from what's in the bulge. So those different colors we see are mostly blue and pink, and that's where we're making stars. So if you remember last week, we learned that the blue stars are extremely bright, and they're also pretty young. So you remember the more massive a star is, the hotter, the bluer, the shorter its life. Live fast, die young. So when you see a bunch of really blue stars like that, that means that stars are being made still. So that's because there's still all this gas and dust that's happening there. It's all running into each other, and it's making new stars. What you see there, though, in the bulge, it kind of looks like there's one giant star. That's just because we're far away, so it kind of looks like one big object. What those are cooler, smaller, redder stars. They live a lot longer. We don't see any blue stars over there. If we did, they'd be much brighter, which means that they're not making any stars in there. So the bulge has cleared out a lot of its gas and dust because it's so close to each other, which means it's not making any new stars. And that's why you'll see when you look at spiral galaxies, the center tends to be a lot yellower, so a lot cooler stars, older stars, and the outer parts where you have all that gas and dust going around is where it's bluer and making new stars. So you may have heard that the center of our Milky Way is the home of a supermassive black hole. In fact, we believe most, if not all, galaxies have one at their center. I'd love to get into that, but actually next week, we're going to be talking about black holes in more detail. So we'll talk more about that next week. Definitely come back. But the way we found this out in the center of our Milky Way is by watching how things move near the center, how stars move. And that tells us how much mass is in the middle. And there's so much mass in such a small area, it had to be a black hole. Like I said, we'll talk more about that next week. But let's keep going out further and further.
So we're definitely not the only galaxy out there, Rémy. Are there galaxies that are right next to us, pretty close?
We do. So the two closest galaxies are called the Magellanic Clouds, and they're technically dwarf galaxies. You can actually see them with the naked eye from the southern hemisphere, those lucky ducks. From the northern hemisphere, we can see with the naked eye our nearest large full-size galaxy. It's called Andromeda. You can see it around fall and winter, so it's not up right now at night. But there it is, there's Andromeda. And it actually...
Right in the Andromeda constellation, so not too easy to forget.
Absolutely. Yeah, so for a long time, they saw that smudge in the sky, the Andromeda Nebula is what they called it, because they thought it was just a regular nebula of gas and dust, although spirally and kind of weird like that. But it was discovered by Edwin Hubble, who proved that that galaxy or that nebula was much, much further away than we thought. And it proved that there are other galaxies than our own. There's Andromeda. And you can see again, that blue and pink making new stars, that yellow and orange, those are older stars. So let's...
And aren't we on a collision course with Andromeda?
We are on a collision course with Andromeda, yes. So Andromeda is in fact 2.5 million light years away. So that collision isn't going to happen for a long while, but galaxy collisions are actually pretty common. So galaxies are actually fairly close together. So stars are pretty far apart. If I've got this dot right here, and that's to scale for a star, the next star might be 15, 20 miles away. However, if I've got a galaxy around the same size to scale, they might be really close like that, which means it's far more likely for them to run into each other. So in the case of Andromeda and the Milky Way, that'll happen in a few billion years.
And I definitely set you up for this question because I wanted to show you, there's this really cool video we have in the system, not sure if you've seen it, but once we collide with Andromeda, our sky, our night sky is going to look different. And I wanted to see if you'd like to see how.
I would love to see how. Go ahead and show us.
Great. So here's our sky today, and then you'll see how it will evolve through our collision.
And imagine getting to see that. That would be amazing. So even though they're on that collision course, it's highly unlikely that any of the stars are going to run into each other. Like I said, they're really far apart. Some of them might get flung out, but for the most part, they'll stick around. So as we go further and further, what you'll notice is the galaxies have different types of structure. Although there are the spiral galaxies like ours, we also have things called elliptical galaxies. Those are the ones that just kind of look like spheres. Those are usually like yellow and orange, which means it's older, they're not making new stars. But you'll also see some that look kind of weird. We call those irregular galaxies. It's kind of like our miscellaneous category. Those usually come about from galaxy collisions like the one we'll have with Andromeda. You saw where it looked really weird in the sky? That might be an irregular galaxy. So we can take a look at what a collision might look like from afar.
Absolutely. And this video is really neat because you'll notice that through the video, it'll pause and it'll show real pictures of these galaxy collisions. Now, we've seen several sets of galaxies collide. This isn't just two galaxies that we were able to watch forever. So we've seen plenty of different sets of galaxies on this different path of collision. It's really neat.
So what we're showing, it's a computer simulation because watching an actual collision take place would take billions of years. We don't have that kind of time. But like Amanda said, those are real pictures, like that one right there, a real picture that shows that our computer models are probably pretty accurate. Those are lovely. That's how we get a lot of our irregular galaxies. After a collision kind of messes up the usual structure of those galaxies.
Ah, that's right. I forgot. Milkdromeda will be the name of our galaxies colliding.
Milkdromeda, I love it. So let's go ahead and keep going and see a little more of the universe and a little more of these galaxies as we go. And Amanda's made them a bit bigger so we can see them better. And all the dots you see, all those pictures, the pictures you see are real pictures aside from the Milky Way, and all the dots represent an actual galaxy. So these are places where there are actual galaxies. We're not just making stuff up and throwing it up there just because it looks cool. And you'll notice there is a structure to it. There's a bit of a structure. You've got these clumps of galaxies that are together. We call those galaxy clusters. And there are areas where there's less galaxies. Like I said, it's gravity that holds things together on a large scale. That's what keeps galaxies together. It also keeps galaxy clusters together like that. So that's why they kind of cluster together. And this big structure that you're seeing as we go through it, it's called the cosmic web. As we go through, you'll see it does kind of look like webbing.
The other thing that's really cool is if you look at a brain and you look at the connections between a brain, it looks a lot like this cosmic web. So you could even say that maybe you have your own universe inside your own mind.
That'd be pretty cool.
Pretty psychedelic.
Absolutely. So we'll go out further and further so that we can see more galaxies. There are billions and billions of galaxies out there. And that's how many light years away we are from home down there. That's a pretty big number.
That's far away.
It's pretty far. We are billions of light years from home. And you'll notice as we kind of move around and add more data that there are some blank spots in our data. So let's go out a little bit faster so we can see. So see how there are areas where there's less. So that's not because there aren't galaxies there. There are definitely galaxies there. We just happen to not be able to look there. And that might be because the gas and dust in the plane of our Milky Way is preventing us from seeing over there, or maybe we just don't have a telescope pointed that way. And really quick, the different colors that you're seeing here, you know, where you saw like the reds versus greens, that's just the density, like how many galaxies are close to each other there. So here we go, we're getting out further and further. And like I said, those areas with nothing, there is something there. It's highly, highly likely that it looks about the same in all those areas. And eventually we're gonna start getting over to the edge of our universe.
The edge of the universe. We've made it.
Here we go. So what you're seeing here are not galaxies. This is called the cosmic microwave background radiation. This is the edge of our observable universe. So the universe hasn't been around forever. In fact, it's only been around for 13.8 billion years. It had a beginning point, which we believe was the Big Bang. So all the matter and energy was concentrated into a single, infinitely small point, and then eventually just exploded outward, expanding outward and outward and outward, and eventually becoming the universe that we live in today. So the cosmic microwave background radiation is leftover radiation from the Big Bang, when the universe was just too dense to see through. Light takes some time to reach us, which means that the further away we look, the further back in time we see. And that cosmic microwave background radiation, say that 10 times fast, is the oldest and farthest thing that we can pick up.
And it has taken so long, it's so old, that by the time it's gotten to us, it's not as intense anymore. And we can actually hear the cosmic microwave background through your radio. So sometimes if you're flipping through radio stations on your drive to work and you land on a static station, you might actually be listening to the beginning of the universe. So that's pretty cool that all this light has finally gone quiet enough to where we can hear it.
Absolutely. So the universe began as this kind of chaotic mess of mass and energy. And as time passed and gravity started taking hold, that's when galaxies began forming. And I believe we have a really cool video showing what that looks like.
Yeah, we sure do. And this is a great time to pull out your gentle, beautiful music, because this is a gorgeous video that is accompanied by wonderful music.
Absolutely. So what you see at the beginning here is just that matter and energy from the very beginning of the universe, and it's just out there. But as there are different areas that are kind of irregular, where maybe there was just a little bit more mass, you see gravity start taking hold. And this takes a really, really long time, millions, billions of years to start doing, but you can see how it starts looking like that cosmic web, that pattern that we saw earlier when we were flying through the universe. There we go. And now we're getting our galaxies in there, and you can see just how that gravity is starting to take hold. And that's what keeps the universe kind of having that structure. What keeps galaxies together, what keeps stars together, what keeps planets together. So with that, it is time to move on to your questions. So while we turn off slow mode in the chat, I'm going to start with a pre-submitted question from Hudson, who asked, what is dark matter and what is dark energy? So firstly, they don't actually have anything to do with each other. So dark matter is matter, whose effects we can observe, but we can't actually see. So I've mentioned before, we've mentioned a few times that we can measure mass based on how things are moving and how gravity works. So the reason we know the mass of the sun, say, is because we can measure how fast all the planets are going around and get an idea of how much mass there is affecting that planet. So the same thing can be done with galaxies. Here we go. And how far away you are from an object does dictate how fast you're moving. So you've seen before that planets that are further away move slower because they're further away and less affected. So you'll see there on the left, you see the graph that goes like that. That's how we expect galaxies to move, because you have more mass in the center. So as you get further and further away, it should kind of go slower and slower. If you see on the right, though, that's what we actually observe. Even as you're getting further and further away, those stars are still moving at around the same speed near the center, which means that there's a lot more mass in there than we're actually seeing, because we can see just how much mass we're looking at versus how much mass there actually is. And that's a pretty big mystery on what exactly is the nature of that matter that we can't even detect. And maybe one day you can decide to pursue astronomy and you could be the one to crack the case on dark matter. You've got dark energy, on the other hand. That's a force that's causing the expansion of the universe to speed up. So our theories tell us that gravity, that I've been talking about a bunch, should be counteracting that initial force from the Big Bang. So the Big Bang expanded outward, and gravity should be contracting things, which it did. You saw earlier on, it made those galaxies, it keeps galaxies together. And what we expect to see when we look at the speed of expansion is that it slows down as we get closer to now. So as time goes on, it should be slowing down. But what we see is actually there's some sort of force that's making the universe expand faster and faster. That rate of expansion is getting larger. And what's causing that, we call it dark energy. And this expansion is actually happening so fast that the distance from edge to edge of the universe, you would expect it that the distance from where we are to the edge would be 13.8 billion years, right? Because that's how long light has had. But the expansion is so much that the diameter is about 93 billion light years across. So instead of like 26 to 28 billion light years across, we're seeing 93 billion. That's because of that expansion, and that does have to do with that dark energy. And that's another mystery astronomers are working on, and you could work on too someday. So let's see what other questions
we could get some answers. Definitely.
Yeah, definitely, please. So we've got, what are the color differences we're seeing in the cosmic microwave background? Let's take a look at the cosmic microwave background again. There we go. So those are really, really, really tiny fluctuations in temperature. And the difference between the red and the blue is only about 0.0002 degrees, but we make them look a lot like a bigger difference so that we can actually see those. And those temperature fluctuations, they led to some colder spots coming together to form more matter slowly, and it starts to form that cosmic web that we saw before due to gravity. We've got Gabriella from earlier this week wanted to know how many galaxies are there. There are about 2 trillion that we've cataloged. And there are definitely more and more out there. So think about how little of the universe we've probably seen, 2 trillion, and then just expand on that. There are trillions and trillions of them. And Amanda, what do we have here?
This is the Hubble Ultra Deep Field. And so Hubble looks at some of the darkest patches in the sky and takes a few day or week exposures and gets this incredible picture where these are all galaxies.
So there are thousands of galaxies just in this one image that was just a tiny, tiny part of the sky. So we had another question earlier this week. How many black holes are in the Milky Way? So there's one super massive one at the center. And then there are also smaller ones called stellar mass black holes. Those come from stars. Again, come back next week to learn a little bit more about black holes. And there's an estimated 10 million to a billion of those wandering around the galaxy. But it's kind of tough because they don't give off light, so we can only see certain kinds of black holes. or stellar black holes. And we've got one more question from Dylan, who asks, what got you interested in space? What am I most interested about regarding it? And why am I so awesome? Live long and prosper. Well, back at you, Dylan. Live long and prosper. So personally, what got me interested in space was actually the Magic School Bus episode, Lost in Space. It's the first episode of Magic School Bus, and I watched it and I thought it was the coolest thing I'd ever seen in my life. And I immediately like went to the library and rented like all these books on space and made my mom rent, and I'm going to age myself here, a bunch of VHS tapes about space. And it just kind of went from there. That was like preschool. What about you, Amanda?
That's awesome. That's beautiful. Yeah, I remember just being a kid, and I think it's funny, once I got into high school and I realized what constellations were, I realized that I've been staring at Orion like my whole life. As a child, I always said, I could see that half smiley face. I always thought it was a half of a smiley face. And then when I found out it's an entire constellation, it was an entire constellation of its own. It was so cool, and I just wanted to learn about the stars in that constellation, and I just kind of went from there.
That's awesome. That's really exciting.
Heck yeah, I like yours too.
Yeah. And why are we so awesome? That's just the way, man. I wish I could tell you, but it just goes naturally. Everyone at Fiske is awesome.
It's true.
So last call for any sort of questions you have. All right. Well, if that is all, thank you so much for joining us. We had a blast. I hope you did too, and you were able to learn something. Again, come back next week. Amanda and I are going to be giving it next week, talking about black holes. Go ahead, and if you have another question, leave it as a comment, submit them. There's a link in the description where you can send us your questions in advance. Thank you so much for watching. Don't forget to like the video, subscribe for updates for more videos like this, and even share the video with friends if you enjoyed it. So from all of us here at Fiske, thank you so much.
See you guys next time.
Bye.